Good day to all. This session we'll see about RAID. So RAID stands for Redundant Array of Independent Disk. So this topic we are going to see how the data item in the disk are organized, how the disk could be managed. So we have got different levels of RAID starting from 0 to 6. So I will tell you what each level is and how the data in the disk is being managed, or how a disk is being partitioned for each level. So first we'll start with RAID level 0. So the name of the level is block stripping non-redundant. So block stripping non-redundant in the sense, if you could see, for each disk the data item is stored blockwise. So A1, A2, A3, A4. So information is stored blockwise. So block of information is stored and each block is going to be non-redundant. So if you could see in the diagram, there is no redundancy, or there is no repetition of elements in the disks, different disks. So A1, A2, A3, A4, A5, A6 and so on. If you could see RAID level 1, it is again going to be block stripping only, but we have got redundancy over there. So it is named as mirrored disk with block stripping. So in the diagram, if you could see, in disk 0 we have blocks from A1 to A4. The same redundant information, same A1 to A4 being block stripped in disk 1 2. So that is with level 1. And level 2 is same kind of block stripping. Along with that, we have got an error correcting code. That code is going to be stripped bitwise. So the information is put in different disk from the 0 1 2 3, we have got blockwise of information which is not redundant. And if you could see from disk 4 to 6, we have got uh, with stripped error correction code. So we have got the ECC error correction codes which has been stripped along with the original data. So whenever we want to check for the originality of information over here, we can access to the corresponding error correction code and we can confirm it with the originality of the information located over there. That is RAID level 2. RAID level 3 is going to be a bit interleaved parity. In previous one, we had the error correction code along with the original information. Here, we have a parity bit along with the original information. So we have got information block stripped in 3 disks, right from 0 to 2. In the last disk, we have the parity bit for each blocks. And in level 4, we have block interleaved parity. So what is the difference with the bit interleaved and block interleaved is, here the parity is interleaved bitwise. So bit 1 to 3, bit 4 to 6, bit 1 to 3, and for a block B, bit 4 to 6 for block B. It is like that. So here if you could see, original information put in 3 disks and the parity bits in the last disk, and the parity bits are all block interleaved. So this is the parity bit for block A1. This is the not block A1, it is for block A. This is for block B. This is for block C completely, the blocks. Previous one, it corresponds to bits from 1 to 3, bits from 4 to 5 and so on. And fifth level is block interleaved distributed parity. By the name you can understand that unlike the previous level where all the parity bits are put together in the same disk, here you could see that the parity bits are distributed in different disks along with the original information. Here A1, B1, C1 or block of information, along with that the parity bit DP is stored. Here if you could see A2, B2 and D1 are the block of information, along with that parity bit CP is stored. So here it is block stripping of information with interleaved distributed parity. Here and there the parity bits are interleaved or distributed. And next one, last level is P plus Q redundancy. So along with a parity bit, we have other one Q parity also. So if you could see A1, B1, C1 or block of information in this particular disk, along with that we have a parity DP, we have a parity EQ also. So we have one more parity bit along with the previous parity. Like in previous level 5 we had parity P. Here we have parity P plus Q. So all these seven levels of parity right from 7 levels of rate right from 0 to 6 are just telling you on how the information is being arranged in a disk or how a disk is managed. So uh, if I could recollect it, 0 is just the block stripping with no redundancy. So we have blocks from A1 to A8, no redundant. Here, level 1, we have block stripping but with redundancy. In level 2, block stripping. Along with that, we have error correction code, which is bit stripped. And level 3, we have interleaved parity, which is bitwise. In level 4, we have interleaved parity blockwise. In level 5, we have interleaved parity only, but it is distributed. And level 6, along with the existing parity P, we have one more parity Q. These parity bits are actually used for any error correction or just to check for the originality of information, whether fake information is being added or the information is being changed. We can just check with these error correction codes or the parity bits. So this is how the disk are managed with the help of the different levels of RAID. Good day to all. This is Remya Rose, Assistant Professor, Department of Artificial Intelligence and Machine Learning from RMD Engineering College. This video we'll see about the different types of indexing. So diagrammatically, if I could discuss about the indices, we have ordered mainly indexes or indices are ordered into two types: ordered indices and hash indices. Among the ordered indices, we have primary indices, secondary indices, multi-level indices. Again, primary indices is being partitioned into dense index as well as sparse index. So first we'll see about the ordered index. So ordered in the sense we know what index is, right? Like normally if we have a textbooks of 500 or 1000 pages, we will have an index page. So index is going to be a key to something that is being loaded behind. So when I want to access something where I don't know the proper location, I can go to the index, find the location which could be a page number, and we will just jump into that particular page and read the information. Similarly, when we keep loading information in a database, when we want to access the information on a right way or proper way or easier way, we normally go for indexing so that the information could be ordered in a way and could be retrieved easily. So an ordered index is a way where which your index is going to be in a sorted way, or your key value is going to be in a sorted way. So ordered could be a primary or a secondary or a